this problem says, right? This problem says this, that I take 250 milliliters of a solution of sodium sulfate, right? And 100. I take 250 milliliters of a solution of sodium sulfate. Is everybody okay with that? Solution of sodium sulfate, yes? Ellie, you all right back there? Excellent, well done. And I mix it with plenty of barium chloride. Now, I precipitate out 5.28 grams. Everything else is soluble, right? We'll pretend. And I precipitate out, that's what the arrow is. I precipitate out 5.28 grams of barium sulfate insoluble. Clear? That's what I'm making. All right, now, this is the question, right? Okay. If I precipitate out 5.28 grams of barium sulfate, what is the molarity of the solution I began with? Very similar to the last problem, isn't it? Try to think, what do I have to do? What do I have to do? Yes? I find the mass of this, right, good, excellent. I find the mass of this, and then what do? I convert that to, starts with an M. I convert it to moles, right? And then I set up a proportional relationship, that many moles based on that mass, that produced that mass, over 250 milliliters equals X over 1,000. Okay, I seem to think that we need a little practice, okay. So let's do the stoichiometric masses. Shall I be your periodic table and part-time calculator? Sodium is 23, that's 46, that's easy. Sulfur is 32, oxygen is 16, times 4 is 64. 64 and 32 is 96. 96 and 46, 142. I also, when I was a kid, I have a little dyslexia, just a little bit, and I used to always, as a kid, believe it or not, make my numbers upside down sometimes. Really weird, I know, go figure, right? 9s and 6s, really tough. 4s, can you imagine making a 4 upside down and thinking that's right? Okay, 1, I get it. Okay, now what is going to be 1? I think you just made fun of me. So barium is 137, is that right?
Yes.
137 plus 32 plus 64. What's that? 233.
Yes.
232.
So, again, we're going to say our known ratio, okay? Sodium sulfate over barium sulfate equals 142 over 233 equals X over 5.28. X equals what? What does X equal? Okay. What is it?
3.21.
3.21. Is that right? Do we have a verification on that? 3.21? 3.22. Excellent. You guys are getting good where you care about a 1,000th of a gram. I like that. I like that. Sharpness. Okay, now, this is the deal. So, what mass of sodium sulfate am I going to need? What mass of sodium sulfate am I going to need? What is it? In other words, right, what mass of sodium sulfate is in 250 milliliters? What mass? 3.22 grams, right? Yes? Okay? So therefore, I say, well, all right, let's convert that to moles, right? So I could say this is going to be 250 milliliters. And what's moles? Isn't it just grams over gram molecular weight? Right? So I could say grams over gram moles, right? Equals helping other students is something that should be embraced, Linda. Thank you. I appreciate that. And she's happy too when she hears the information you gave her relative to stoichiometry. I like that. You're such a wonderful teacher.
Linda really makes me love stoichiometry.
You know, you look like you love stoichiometry. When I think of Neve, I think of stoichiometry.
I thought you loved chemistry.
Well, I think of it's multifaceted. It's a mixed thing, you know. It's great. It's wonderful.
I want Santa to replace stoichiometry.
Excellent. And I will see what I can. I'll see what I can do. Okay, so this is going to be. I want to divide this by 1 mole. So it's going to be 3.22 over 142 over 250 equals x over 1,000. What's x?
9.
It's going to be, what's 3.22 divided by 142?
0.22676.
No, I need, Mr. Salmon, you know better than that. I just need 3 seeming figures. So what is 3.22? Okay. Can you remember that your teacher has really bad hearing? So,
0.022.
yo! Excuse me?
0.023.
0.023. Right? Yes?
Yes.
So I can erase this here, right? And I could say 0.023, right?
Yes.
So what is 0.023 times 1,000 divided by 250?
0.290.
0.9.
0.9.
Wait, Mr. Salmon,
0.9.
I'm just getting
your timing is terrible. Don't join a choir until you figure that out, okay? I'm sure that you're a wonderful singer, but your timing is utterly atrocious. Aaron, thank you for not messing with the knobs for the gas. I appreciate that. Excellent. Well done. Okay. All right. No one speak and let Mr. Salmon test out his newfound timing.
0.092.
0.092.
No.
Yes.
Yeah.
0.091. 0.92. How? You could just use 0.023 instead of the whole decimal space.
Guys, you're getting a little crazy, okay? It's a little crazy. 0.091, 0.092, it's okay. It's called round off error, okay? Gabby, you're getting a little, obsessive, okay?
Ella? Yeah, Ella.
Okay.
Sorry. We have Ella.
Ella,
Belen.
Belen,
And Neve I've spoken to.
and Neve I've spoken to. I'm sorry. Now, are they going to be gone for a long period of time?
No.
Could we try to remember that I'm filming? It's okay. You've been marbleized. Okay. Now, so it's going to, the answer is going to be 0.992,
0.9. No.
2, yes.
right? Because it's going to be, X is going to be 0.092 moles, right? 0.092 moles over 1,000 milliliters is the same thing as 0.092 molar. Okay? That fits on the screen perfectly. All right? So that number is number 100. All right? You all right with that? Okay. Antoine, you okay? All right. Yes. Wait, let me get this straight. You're asking me a question. I really like this. A new era is dawning on mankind and womankind. Alec is asking me a question. It's June 2nd. Let me get this straight. June 2nd, 2015. Alec is wonderful. I'm very impressed. Alec, continue, please. I'm not making fun of you. I'm actually excited. Carry on.
So x equals 0.092.
Correct. And that's the number of moles, right? So why am I saying 0.092 molar? By the way, I can hear you very well. I can hear good low frequency voices. I like that. I like that a lot. All right, so Alec, do you understand when I say the answer is 0.092? 0.092 what? Well, it's 0.092 moles, but that's not the answer. So in other words, if you put 0.092 moles on your test paper, it would be wrong. You'd have to put 0.092 molar. You get it? Because what I'm asking you is what is the concentration of the solution? You have 250 milliliters of water. Dissolved in there, you have some quantity of sodium sulfate. What quantity of sodium sulfate? Well, if you do a mass-mass stoichiometric conversion, you find out that you have 3.22 grams in here. All right, I have 3.22 grams in there, but I don't want it in grams per volume, grams per milliliter. I want it in moles per 1,000 milliliters. And we call that molarity. Okay? Now, so what you're going to do is molarity is moles per 1,000 milliliters. So I'm going to convert 0.023 moles of sodium sulfate. Where did I get 0.023 moles of sodium sulfate? Where did I get that from? I found I had 3.22 grams, right? So I converted this value to moles, and then I said, well, I have that many moles over 250 milliliters, right? But that's still not molarity. But this concentration has the same concentration as the stated molarity. And the molarity would be that value, which is here, 0.023 over 250 equals x over 1,000. So I found that x is 0.092 moles, right? 0.092 moles over 1,000 milliliters as a concentration is called 0.092 molar. Okay, you get it? That's the molarity, the concentration. Okay, we're off.